Hi to everyone. I am Dr. VNSR Venkateswara Rao, working as an Associate Professor in Institute of Aeronautical Engineering College, Hyderabad, Telangana. Today I would like to give the topic on the conductometric titration. So conductometric titration is nothing but one of the instrumentation titrations to determine the endpoint of the various reactions like neutralization reactions, precipitation reactions. Almost all conductometric reactions are more accurate results compared to the classical methods of analysis. So what are the contents involved in the today's topic are mainly introduction to the conductometry. That means what are the basic parameters involved in the conductometry, and what are the factors involved in the conductometry, and what is the main principle, that means instrumentation principle involved in the conductivity and conductometric ions, and what are the types of conductometric titrations. Already I said that neutralization and precipitation reactions are mainly involved in the conductometric reactions, and finish the topic with advantages, disadvantages with their applications related to the so many fields. So this is about the what are the contents involved in the today's topic. So first of all, what is the conductometry? Conductometry is nothing but to determine the endpoint of a reactions like neutralization and precipitation reactions. That means the endpoint of a reaction is determined with the help of conductivity measurement. With the help of conductivity measurement, it is nothing but a conductometric titrations. Conductometric titrations. That means in the case of the classical methods of analysis, the titration involves the titrate and the titrant, and to determine the endpoint of a reaction, that is nothing but a classical methods of analysis. But classical methods of analysis involves the so many errors, but whereas those errors are overcome in case of the instrumentation titrations. The best example for the instrumentation titrations is the conductometry titrations. So conductometry is the measurement of the conductivity of a solution due to mobility of cations and anions to be towards the respective electrodes. That means generally conductivity is defined as the reciprocal of the resistance. That means what are the units for resistance? Ohms. What are the units for resistance? Ohms. But conductivity is nothing but the reciprocal of the resistance. Reciprocal of the resistance. Then units becomes ohm inverse. That means the conductivity is mainly due to the mobility of ions. Mobility of ions. So that mobility depends upon the charge on the species. That means it maybe depends upon the either positive charges or negative charges. That's why conductometry is the measurement of a conductivity of a solution due to mobility of cations and anions. Whereas positive charge species are called as cations and negative charge species are called as anions. So it depends upon the charge on the particular species, the conductivity proceeding takes place. So because of the mobility of the ions, the conductivity proceeds. According to the formula, conductivity is nothing but a reciprocal of the resistance. Now see what are the factors affecting the conductivity. What are the factors affecting the conductivity? So that means generally the conductivity is due to the ionic species. Ionic species. That means depends upon the various parameters of the ions. The conductivity may be either directly proportional or indirectly proportional to species. So there are mainly four factors which affects the conductivity. First one is the number of the ions, nothing but a concentration of the species. Second one is the charge of the ions, that may be either positive or negative. And third one is the size of the ions. And final one is the temperature of the ions. Let us explain whether it may be directly or indirectly proportional to conductivity. So first of all, number of the ions. When number of the ions increases, automatically conductivity also increases. That means concentration of the ions, directly proportional to conductivity. That means when concentration of the species increases, conductivity also increases. For example, if you can take in the solution like hydrochloric acid or sodium hydroxide, those are nothing but a strong acid and a strong bases. When concentration increases from 0.1 molar to 1 molar concentration, that means the concentration will be increases from 10 times from initial to final. From initial to final. Whenever the concentration increases, automatically the number of the spaces or number of the ions, including the total solution, will be increases. That means concentration increases. So when the concentration increases, conductivity also increases. And second one, charge of the ions. Charge of the ions mainly classified into two types. Charge of ions mainly classified into two types. That may be either positive or negative. Positive species are called as cations, and negative species are called as anions. So it depends upon the charge. Nothing but a polarity on the species. It may also affect the conductivity of the solution. That means whenever the charge increases, that means positive charge increases, the size of the ions will be decreases. Whenever the negative ion increases, the size of the ions will be increases. Further, the size of the ions will also affect the conductivity. That means when charge increases, that means depends upon the polarity. That may be when positive charge increases, the size of the ions decreases. Automatically, when size decreases, the mobility increases. Mobility increases. When negative charge increases on the species, nothing but size of the ions will be increases. The size of the ions will be increases, automatically the mobility will be decreases. So that means it depends upon the charge of the ions. It may be either directly proportional to conductivity or inversely proportional to conductivity. Depends upon the polarity of the ions. Next, third one is the size of the ions. Size of the ions, nothing but when size increases, the mobility decreases. When size increases, mobility decreases. So when mobility decreases, automatically what happens? Conductivity also decreases. Conductivity also decreases. So I said that when size of the ions is inversely proportional to conductivity. And final one is the temperature of the ions. When temperature increases, what happens? Moment of the ions will be increases. Moment of the ions will be increases. When moment increases, mobility also increases. When mobility also increases, conductivity also increases. That means temperature is directly proportional to conductivity of the species. That means once again I am telling about what are the factors affecting the conductivity. So first one, the number of the constant ions, nothing but the concentration. When concentration increases, conductivity also increases. That means the number of the ions, concentration of the species directly proportional to conductivity. Again, charge of the ions. When charge of the ions increases, the mobility also increases. Depends upon the polarity, the mobility depends upon. So when charge increases, automatically the mobility increases directly proportional to conductivity. But in case of the size of the ions, when size of the ions increases, the mobility decreases. That means it should be inversely proportional to conductivity. But final one, temperature. When temperature rises, the moment increases, automatically mobility rises and conductivity also increases. So out of the four factors, three factors which are directly proportional to conductivity, and one factor nothing but size of the ions which is inversely proportional to conductivity. And what is the principle involved in the conductometry? That means the main principle in this method that the moment of the ions creates the electrical conductivity. That means because of the moment of the ions, mobility produces, when mobility produces, it causes the conductivity. That means the moment of the ions is mainly depends upon the concentration of the ions and the electrical conductance according with the Ohm's law. That means the main principle involved in the conductometry is nothing but a Ohm's law. Ohm's law. What is Ohm's law? According to Ohm's law, the current passing through the object, nothing but a conductor, is directly proportional to the potential difference and inversely proportional to the resistance. That means the current I is equal to V by R. That means according to this equation, the current should be directly proportional to the voltage difference or potential difference and inversely proportional to the resistance. So it is the main principle involved in the conductometry. So there are so many conductivities present in our physical parameters, but out of all the conductivities we measured only specific conductivity. So that means what is the first of all possible conductivities? First one is the molar conductivity. Molar conductivity, and second one is the equivalent conductivity. And third one is the specific conductivity. So out of three conductivities we measured specific conductivity by the conductometry. What is the first of all molar conductivity? Molar conductivity is defined as the number of the gram moles of the solute present in 1 liter of the solution. That is nothing but a molarity. That means the conductivity offered by a solution present in the 1 gram mole of the substance is nothing but a molar conductivity. What is equivalent conductivity? The conductivity offered by a solution having 1 gram equivalent of the substance. What is specific conductivity? The specific conductivity offered by a solution having a square centimeter area. Square centimeter area. That means area is equal to length into breadth. That means centimeter into centimeter to get a square centimeter area. That means both length or breadth should be equal. That means we consider a square. Consider a square. So the total number of the ions present in that square, because of the moment of the ions present in that particular square area offered by a conductivity comes under the category of a specific conductivity. That means what is the specific conductivity? It is defined as the conductivity offered by a substance of 1 centimeter length and 1 centimeter breadth. Finally, it causes the 1 square centimeter surface area. And what are the units? Mohrams, centimeters, inverse. Why you get these units? Generally, what are the units for conductivity? Ohm inverse. And we consider the square centimeter area. That's why we get the inverse square centimeter. So it is the units for square centimeter area, and it is represented by k suffix small b. It represents the specific conductivity. Again, specific conductivity is inversely proportional to specific resistance or reciprocal of the specific resistance, where rho is called as a specific resistance, and it is also offered by a substance having a square centimeter area. So generally, what are the units for resistance? Ohm inverse, including you consider the area. That's why we had the unit to centimeter. So what are the units for specific conductivity? Mohrams, centimeter inverse. What are the units for specific resistance? Ohm, centimeters. So out of the three conductivities, only specific conductivity is measured by the conductometry. So it is very, very important because of the measurement of the specific conductivity. So conductivity is inversely proportional to the size of the ions. So it should be satisfied according to factors affecting the conductivity. So that's why the size of the ions will be inversely proportional to conductivity. But molar conductivity and equivalent conductivity does not affect the size of the ions in case of the conductivity. Only equivalent conductivity should be inversely proportional to the size of the ions. So this is nothing but the experimental setup of the conductometric titration. This is called as digital conductivity meter. Digital conductivity meter, and it is made by the Electronics. Electronics. So it is one of the famous manufacturing company to supply the physical parameters instruments. So it made with the digital pH meter and the digital conductivity meter and digital potentiometer and the digital ECTDS meters. Almost all the meters are made by the Electronics manufacturing company. So it is the made with the Electronics, and it contains the one glass electrode. It is called as conductivity cell. Conductivity cell. So the cell is very important to measure the conductivity present in a given sample solution, analyte solution. Analyte solution. That means the first parameter is it is made with the Electronics, and it having a conductivity cell. Second one, and third one is the analyte solution. Third one is the analyte solution, and it having a digital display. Fourth one is the digital display. Okay, so before starting the experiment, first of all, we can calibrate this conductivity meter with deionized water. Deionized water. So what is the meaning of the deionized water? The sample of the water should be free from all the dissolved salts, nothing but a deionized water. So by using that deionized water, we can calibrate this instrument whether it is working performance is suitable or not for measuring the conductivity present in various types of the samples. So this is mainly the experimental setup of the conductometer, and very important thing is the conductivity cell is made with the platinum plates. Platinum plates. Why you can choose the platinum plates? Platinum is the very more stable element compared to the other elements. Why? Because its standard reduction potential is very high compared to the other elements, and it should be stable even in the presence of the any type of solution, especially acids. So that's why we made the conductivity cell with the platinum element. So this is the components which are present in the conductivity meter. So what are the types of the reactions involved in the conductometry? Mainly two types of the reactions involved in the conductometry. First one is the neutralization reactions. Neutralization reactions, and second one is the precipitation reactions. Precipitation reactions. What is the neutralization reactions? When acid and base react to give the neutral compound, so that is nothing but a neutralization reactions. Generally, neutralization reactions gives the classical methods of analysis, but we move from the classical methods of analysis to instrumentation methods of analysis. Why need of this classical instrumentation methods compared to the classical methods of analysis? In this case, there is no need of the indicator. There is no need of the indicator. That means chemical consumption is low, and the titration should be possible even at very low concentrations. Even at very low concentration. Mainly based upon these two reasons, we are moved from classical methods of analysis to instrumentation methods of the analysis. So, and what are the neutralization reactions involved in the conductometry? First one is the strong acid, strong base, and the second one weak acid, strong base, and third one strong acid, weak base, and fourth one weak acid, weak base. So this is the main titrations which are involved in the neutralization of the conductometric titrations, and the precipitation reactions involved in the mainly determination of the chloride. So these are the main types of the reactions involved in the conductometry. Now, what are the first type of the reactions in case of the conductometry neutralization reaction? That means the titration takes place between the strong acid and the strong base. What is the example for strong acid? Hydrochloric acid. And what is the example for strong base? Sodium hydroxide. When both are interrelated or interlinked to give what happens? Sodium chloride. Sodium chloride is the best example for the neutral compound. Because of the formation of this neutral compound, this is the comes under category of the neutralization reactions. Now we see what are the polarity depends and develops in the case of the titrations. That means initially we consider HCl. That means it dissociates into H plus and Cl minus ions. And sodium hydroxide dissociates into Na plus and OH minus ions. It gives the sodium chloride. That means Na plus and Cl minus and H2O. H2 means H plus and OH minus ions. So we see initially what happens that H plus ions are replaced by the sodium ions. That means sodium ions are first group elements and hydrogen ions also first group element. In case of the periodic table, what are the periodic properties? Where we move from top to bottom of the series. What happens? The size will be increases. When size increases, the mobility also decreases. That's why initially in the graph, what happens? It starts with high conductivity. Due to presence of H plus ions. But when the titration going on, what happens? That H plus ions are replaced by the sodium ions. So whenever the H plus ions, smaller H plus ions replaced by the sodium ions, larger ions, automatically the conductivity will be decreases. That reduction of the conductivity continue up to the end point of the reaction. But after the end point, because of the presence of the OH minus ions, excess OH minus ions, again the conductivity will be rises. So that's why we get a graph, nothing but a V-shaped curve. So this is the main reason involved in the titration of strong acid with strong base. That means when the base is added to the HCl solution, the conductance falls due to the replacement of the hydrogen ions by the added cation as H plus ions react with the OH minus ions to form undissociated water. So after the equivalence point, the conductance increases due to the large conductivity of the OH minus ions. This is the first type of the reaction involved in the conductometry. And what is the second type of the reaction involved in the conductometry? That is nothing but a weak acid versus strong base. What is the example for weak acid? Nothing but acetic acid. Weak acid example is the acetic acid. And what is the example for strong base? Sodium hydroxide. When weak acid reacts with the sodium hydroxide to give a sodium acetate, it is the one of the neutral compound with water. So in the case of the weak acid, initially the starts with low conductivity because of the ionization will be very low in the case of the weak acid. That means it cannot easily gives the H plus ions. So H plus ions mobility is less and conductivity is also less. So that will be continue up to the end point of the reaction. But after the end point, what happens? Because of the presence of sodium acetate, it gives the high ionization constant. That means it can easily dissociate into individual ions. So whenever the polarity develops, the mobility also develops and the conductivity also increases. That means initially starts with acetic acid. That means H3COO minus plus H plus ions. The dissociation constant is less, and it reacts with the sodium hydroxide. That means Na plus and OH minus is raised to sodium acetate. That means CH3 COO minus and Na plus, and water molecules H plus and OH minus. So initially acetic acid cannot easily give the H plus ions because of the weak acid nature, and ionization constant is less. But after the end point sodium acetate can be easily dissociates into individual ions. That means polarity develops and mobility rises automatically. Conductivity increases after the end point. That means initially the conductance is low due to the feeble ionization of acetic acid, followed by increase due to the addition of sodium hydroxide. Beyond the equivalence point, steep rise due to the excess of sodium hydroxide. And this is the second type of the conductometric reaction. And what are the third type? Titration of a strong acid against the weak base. What is the example for strong acid? Hydrochloric acid. And what is the example for weak base? Ammonium hydroxide. And product is the ammonium chloride. Ammonium chloride. This is also one of the neutral compound, and this way this is comes under the category of the neutralization reactions, including byproduct is the water molecule. In this case also initially it starts with strong acid. That's why the conductivity initially high because of the easily gives H plus ions, and mobility will be high. That will be continue up to the end point. But after the end point, what happens? Because of the weak base or weak salt, that means ammonium chloride, the dissociation constant is less. That means there is no dissociation in the case of the ammonium chloride when compared to the hydrochloric acid. That means there is no gradual change in the conductivity. That's why it gives the horizontal curve. Horizontal curve. Horizontal curve. That means what happens? H plus and Cl minus, NH4 plus and OH minus ions to give NH4 plus and Cl minus plus H plus and OH minus ions. So initially the H plus ions and the higher mobility, so conductivity starts at a high position. That will be continue up to end point. But after the end point, the product is the ammonium chloride is the weak electrolyte. It cannot easily dissociate individually. So there is no gradual change in the conductivity, and it shows the parallel to the horizontal curve. So initially the conductance is the high, and then it decreases due to the replacement of the ammonia ions. But after the end point has been reached, the graph comes out almost horizontal, since the excess ammonia is not appreciably ionized in the presence of the ammonium chloride. And what is the fourth type? Titration of the weak acid versus weak base. What is the example for weak acid? Acetic acid. And what is the example for weak base? Ammonium hydroxide. So by the combination of weak acid and weak base, it gives ammonium acetate. Ammonium acetate, and with water molecules. That means initially it starts with weak acid. Weak acid means it cannot easily give the H plus ions. That means the mobility of H plus ions is less. Automatically conductivity also less. That will be continue up to the end point. But after the end point, even the salt is also less. That means ammonia acetate. That means there is no gradual change in the conductivity. Similarly, it can also shows the parallel to the horizontal curve. Horizontal curve. That means the nature of the curve before the equivalence point is similar to the curve obtained by the titrating weak acid against the strong base. But after the equivalence point, the conductance virtually remains same as the weak base, which is being added in the feebly ionized and therefore is not much conducting. That means acetic acid means CH3 COO minus H plus plus NH4 plus OH minus is raised to CH3 COO minus plus NH4 plus H plus and OH minus. So this is the main polarity develops in the weak acid and weak base. And what is the fifth type of reaction? Comes under category of the precipitation reactions. In case of the precipitation reactions, what are the reactants involved in the titration? That means initially it starts with the potassium chloride, one of the strong electrolyte, reacts with the silver nitrate, and it gives the potassium nitrate and silver chloride. So it is the main titration involved in the determination of the chloride. Determination of the chloride in various samples. That means initially what happens, the strong electrolyte KCl, K plus and Cl minus reacts with the silver nitrate Ag plus and NO3 minus to give the potassium nitrate and K plus and NO3 minus plus silver chloride and Cl minus. So initially the potassium chloride having a strong electrolyte and it starts with the conductivity, but it reacts with the silver nitrate. The ionization constant is very less. That means there is no gradual change in the conductivity. That means it gives the horizontal curve. But after the end point, because of the strong electrolyte of the potassium nitrate and silver chloride, again the dissociation constant is very high and it will be gradually increases after the end point. After the end point. That means initially the silver nitrate had added, the first part of the curve shows the no increase in the conductivity, as there is only replacement of the chloride ions with nitrate ions. But after the end point, the conductivity increases because of the increase in the concentration of the silver as well as the nitrate ions. That means the nitrate ions having the higher mobility when compared to the silver ions. That's why after the end point, the conductivity will be gradually increases. So these are the main types of the reactions involved in the conductometry. Now let us see what are the advantages and the disadvantages of the conductometry. So in the case of the, what are the advantages of the conductometry? Already we said that where we move from classical methods of analysis to instrumentation methods of analysis, there is no need of the indicator. That means no indicator is necessary. That means chemical consumption is less. Chemical consumption is less in case of the instrument titration while compared to the classical methods of analysis, and it is suitable for the colored or dilute solution. Suitable for the colored or dilute solution. In the case of the colorless solution, we can identify or view the endpoint very easily. But whereas in the case of the colored or dilute solutions, we cannot identify the endpoint. Is very difficult. But by using the conductometry, it is possible to determine the endpoint of a reaction. That's why it is applicable to colored or dilute solution, and the endpoint is determined by graphical means. Accurate results are obtained with minimum error. So we can find out the any type of the reaction, whether it may be neutralization reactions or precipitation reactions. So we can determine the endpoint of a reaction with the help of the graphical representation. Because of the graphical representation, the error will be as much as low. That means the titration error is very low. Titration error is the difference between the endpoint and equivalence point. That means we can get the results more and more accurate, and use it for the analysis of the turbid suspensions, weak acids, weak bases, and mixture of weak and strong acids. Generally, classical methods of analysis applicable to the only individual chemicals. That means strong acid, strong base, strong acid with weak base, or weak acid, strong base. But by using this conductometric titrations, it is possible by the mixture of the acids with strong base. That is the main advantage of the conductometry. And increased levels of salts in the solution masks the conductivity changes. In such cases, it does not give the accurate results. This is the main disadvantage of the conductometry. That means whenever the salt percentage will be increases, that can act as a masking agent. So whenever the masking agent develops, conductivity automatically changes. In those cases, we can measure the conductivity accurately. And application of the conductometric to redox systems is limited. Why? Because we use the conductometric titrations only neutralization reactions and precipitation reactions, but cannot be used for redox reactions. That is mainly drawback of the conductometry, and high concentrations of the hydrogen ions in the solutions tends to mark the changes in the conductance. So these are the main disadvantages of the conductometry. And what are the applications of the conductometry? That means it is mainly applicable to the secondary soluble salts like silver chloride and barium sulfate. Even those salts can be determined. And water pollution in rivers and lakes, alkalinity of the fresh water, and salinity of the sea water. That means even the oceanography, the salt water contains the main salt percentage. In those cases also we can determine the salinity of the sea water by using the conductometry. And trace antibiotics and deuterium concentration even in the water deuterium mixture. And it is also analysis in the case of the food analysis, nothing but food microbiology for tracing microorganisms. And tracing antibiotics is also very important. And at the same time, to determine the ash content in the sugar juices, and the purity of the distilled and deionized water can be determined, and the determination of the atmospheric content, especially sulfur dioxide gas, and finally estimation of the vanilla and vanilla flavor applications. So these are the main applications of the conductometry. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.